Welcome, everybody. Thank you so much for coming out. I have to tell you, I was talking to someone yesterday and told them I was giving a lecture, and they said, "What is it about?" And they said, "It's the story, it's about water at the University of Virginia." And they go, "Who would come to that kind of talk?" So I really appreciate that you're all here to listen to this subject. So thank you, Susan and Patrick and Eric and Teresa, for organizing us, making it very simple to be here. We're honored to be here as a part of the Office Engagement Life Learning Program. So introductions. So I'll start out by introducing Garth Anderson. Garth has what I call the enviable position at UVA. His title is the Facilities Historian at UVA Facilities Management. And he's been at UVA since 1984, and since that time, he's really become the go-to person on the campus for anyone who wants some information about the buildings and the grounds at the university. His office is in charge of digitizing, creating a digitized archive of all the maps and the engineering drawings and architectural drawings that have been created since 1894. Garth says his first job as a supervisor at the blood bank at UVA actually equipped him for his current job because he had to learn how to create large databases and organize huge amounts of information. And that, in conjunction with his razor-sharp memory for dates and events and pulling them together in thoughtful narratives about UVA history, has made him an invaluable and delightful partner in our research on Observatory Mountain. Aaron Cross is trained as a geologist at JMU and later at the University of New Mexico Tech School of Mines. In his early career, he served with the National Park Service as a geologist in New Mexico at the El Morro National Monument. And right now, he is writing his memoirs of his experience there and stories about the rock, the geology, and the interesting carvings that are there at the monument. More recently, Aaron was working at the State Geological Survey out there on Fontaine Park, and he was carrying out a very interesting array of projects. The one that caught my mind was the research that he did on the influence of geology on the Civil War in the South. Aaron's been absolutely invaluable in contributing his knowledge, his immense understanding of the geology here in Virginia and Albemarle County, and it's helped Garth and me really understand the picture of water here at UVA. So, first of all, I have a question. How many of you are alumni or frequent visitors to the university? And the reason that I'm asking that is that in today's presentation, we're going to be kind of jumping around different sites on the grounds. So sometimes we've done our best to kind of orient you as to where we're going to be speaking from. But if at any point you're really kind of lost, like you don't even know where we're talking about, please feel free to raise your hands. So it's a rather fuzzy picture, I apologize. So in 2015, Garth and I began working to uncover the history of this forested mountain track that essentially defines the western limits of the central grounds as we know it. The O Hill is such a familiar backdrop, it's really hard to imagine what the campus would look like if it didn't have that forested background behind it. It goes by numerous names. We've already heard Susan call it Mount Jefferson, but you'll also hear us today probably mixing it up with the other names that it has: O Hill, Observatory Hill, Observatory Mountain, and Mount Jefferson. So while everyone knows that Jefferson bought a parcel of land, it's about roughly 45 acres, on which to build the university, most people are not aware that at the very same time in the same purchase, he purchased 158 acres off to the west, 158 acres, separate, non-contiguous tract of land, but he understood that he needed to have this other tract, which is simply listed on his drawing as mountain. We'll see a clearer view of this in a bit. So parcel on the UVA records, parcel 1A is listed as the first tract, and it's the site where the Academical Village was built. Parcel 1B is lesser known, and it is simply listed as the mountain. And though parcel 1B is lesser known than 1A, Garth and I claim that to really fully understand parcel 1A in the Academical Village, you really have to understand it in the context of both of these parcels together. So our research has covered many material ties over history that connected the two parcels, materials that were flowing back and forth between the two parcels. Some of them are obvious. Wood, stone, water was coming down from the mountain to serve the university. But then our research actually uncovered some really unexpected and really fascinating other materials, things like architectural building debris, medical waste, even uranium that was making its way from the university up to the top of the hill. So there are many materials that we researched in our project, but today our talk is going to focus on water, which is going to be realized in this dark line here, which is Meadow Creek that originates up on the mountain here. So the main points that we want to make today is the water that flowed down in Meadow Creek from parcel 1B to parcel 1A was critical to building the Academical Village and sustaining it in the first, in the early days. That water was also important in shaping the evolving university campus throughout the latter 19th century and well into the 20th century. And today in 2022, the hill still continues to be crucial in serving the water needs of the university community. It sounds a little bit over the top, but Garth and I like to claim that the UVA grounds that we know today evolved in the way it did because of parcel 1, its resources, and its geographical and topical relationship to parcel 1A. So I'll turn it over to Garth now.
Thank you, Nancy. Observatory Mountain. Nancy and I have had that in our active vocabulary for at least 15 years. As principal of Hereford College, she lived on the mountain for 6 years, and I have worked at the base of the mountain for over 25 years. But so many students, alumni, locals, and visitors see it in their viewshed every day, every week, or at least occasionally. If you check out the scoreboard at Scott Stadium, the mountain is behind it. If you drive south on 29, there it is, straight ahead. From Pantops, you get a great view of it. But from so many places on grounds, you can see Observatory Mountain. It also appears in historic prints. W.T. Liddick was famous for their aerial view postcards of college campuses, towns, and cities, large industrial complexes, and other scenes of the grown America. Casimir Bond also printed large scenes, but in various sizes, including up to 2x3 and 3x4 prints. The one at the top is a view of the university from the east, not too oftenly seen. The one on the bottom is the one that we see more often, which is the university. This one is titled View from Lewis Mountain, and is the one we see quite often. It was always in the window of Freeman Victorious on West Main Street. But if you're familiar with walking around grounds, if you're coming down from the rotunda walking west and you have Pavilion 1 on your left, and you're looking straight ahead, Lewis Mountain is straight ahead, and the Campbell Mansion is on the top. if you're crossing McCormick Road and walking up the sidewalk and Alderman Library is on your right, straight ahead is Lewis Mountain with the mansion at the top. So if you look at this scene, it's orthogonal view. So it really isn't a view from the top of Lewis Mountain. And it may be actually better said that it looks like a view from Observatory Mountain. But this is really just the work of a landscape artist. They gather information, artists that go out into the field and do sketches. They do sketches of individual buildings. They get maps of the area, and all that information, landscape artists will compose scenes like this. There's no hot air balloons, anything like that. It's really just taking all of the information and composing these type of scenes. And just to show you one of these, I was going through looking for a particular different view of view from Lewis Mountain, and I found this scene, this item on a brokerage site from a auction about 2 years ago, and this is view from Lewis Mountain. And when you zoom in, you can see that this truly is the view from Lewis Mountain. It's looking straight down and in line with both the Anatomical Theater, which was taken down in order to give better access to Alderman Library, and of course Pavilion 1 is behind it. So this may very well have been the artist who did the field work for the Bond print of 1856. Just one of the pieces that the landscape artist used to develop that. Actually, it was put up and estimated at $600 to $800, and it sold for over $12,000 because somebody knew exactly what they were seeing there. So this is the plat that Jefferson drew of the two surveys that he did, parcel 1A on the right, parcel 1B on the left. And this is what Nancy and I started with, looking at those two and saying, everybody talks about the one on the right, we're going to talk about the one on the left. The Academical Village was imagined and staked out by Thomas Jefferson and two of his enslaved workers on an almost 44-acre parcel, which was the germinal start of the large and complex university we have become today. On the same deed, he bought a 153-acre mountaintop. Men of Enlightenment couldn't get too excited about water flowing downhill, even if it was important for fire protection, livestock, gardens, and the washing of clothes. But this just wasn't potable water. Jefferson spoke about erecting an observatory on the mountaintop, and a small one was built in 1828, but it was never outfitted with any equipment and was taken down in 1859. A small observatory on Monroe Hill was erected and equipped and used as a teaching aid. The mountain became a source of wood, a quarry at the foot of the mountain in today's facilities management compound, provided stone for walls, steps, and thresholds. Parcel 1A is preserved as it was when it was finished in 1825-26, while Parcel 1B has seen all that is new, dangerous, unwanted, and yet all of that can be appreciated with a pair of binoculars, with your dog, with your mountain bike, and all by yourself. In 1825, a second attempt of burying the water pipes put them 3 to 4 feet below the surface in an anaerobic zone where the wooden pipe wouldn't decay. But Jefferson realized that the land that they ran through belonged to John Perry. He controlled the fate of the university's water. He didn't want to be overzealous and approach Perry. So he put together some information to try to prepare for the potential of buying the property, and luckily it was Perry who came to Jefferson anxious to sell the land. He proposed a price of $60 an acre, and Jefferson said, absolutely not, I cannot take that number to the Board of Visitors, and said he would take the number of $50 to the BOV. Perry agreed, and he said, we'll get you money this year, but we'll have to pay you over a number of years because this will come out of the literary fund. And Jefferson didn't want to wait for the next BOV meeting. So he wrote a letter, made copies of this map, and wrote out what he projected to be a budget for the next few years on how this would get paid, and sent it off to members of the BOV. It got approved, and the land was purchased and became the missing link in between the academic portion of the university and the mountaintop. The following year, in 1826, the surveyor Achilles Broadhead created a plan for garden plots, primarily for professors and hotel keepers. Some are large enough for grazing areas, especially along Meadow Creek, which I've outlined in blue. So how did Jefferson come around to being interested in Parcel 1B, the second purchase right at the very beginning? I proposed something about 10 years ago that living at Monticello sort of primed him for this purchase. Jefferson had bought Mount Alto, or at least the portion that was in his viewshed. Monticello to Mount Alto is about 4,850 feet distance-wise, and a difference in height of just over 400 feet. As he was touring Perry's land, if he was on the area of the lawn and he were to look towards the Observatory Mountain, that difference would be about 290 feet. And the distance is about 5,300 feet. Jefferson had very little water up on Monticello. It was basically collecting rainwater into cisterns there. And he actually considered collecting water from Mount Alto, where there was a spring, and piping it over to Monticello, and actually did a sketch outlining that. He never did it, but it was in his head of the possibility. He also drew a design for an observatory for the top of Mount Alto, which was never built. So we had those two priming experiences. But I really think it was when Jefferson was touring the land that Perry had that he may very well have been around on Monroe Hill. And of course, this was the land that Monroe had. That was his lower plantation. And there was Monroe's house and Monroe's law office up there. And he may have just stepped up behind the law office and looked west and been faced with this view that that Holsinger captured in 1913 of the golf links, and thinking about the view from Mulberry Row at Monticello. And to me, the two are so close that he may have just said to Perry, "Do you own that mountain up there? Are there springs up there?" And said, "I think we need to talk about purchasing that as well." That's my idea of that. Mont Alto was the sort of prime to his purchasing the mountaintop. So we've talked about water collection and pipes from the mountain, but water was also collected at the Academical Village. Rainwater from rooftops was gathered into cisterns. The 1825 Maverick plan shows 6 cisterns, which are circled in red. And then also in the Pratt map, and this is just a close-up of the area around the rotunda, on each side in the courtyards, there are 2 cisterns there. And during the recent refitting of the rotunda, archaeologists went in and rediscovered that cistern there, which was quite large and very deep. I think it was over 60 feet deep, and would have held about 30,000 gallons of water, which would have come off of roofs, both the rotunda and the annex. And I was sort of thinking, how might he need that much water and the like? And one of the things that came to bear was that there was a system being put in there the next couple of years, and that was 1859, a design that Montgomery C. Meigs, the brilliant Army engineer, put together, that developed both hot air and steam heating for the annex and the rotunda. And I'm not sure when it was actually installed, but the design was 1859. And in the north end of the basement, let's see if I can get this pointer, right in this area here, that's where the heating boiler is, but there was also a steam engine for pumping water. and that was used to both pump water up into tanks in the portico of the rotunda that was up there for the potential of fire, so it would be a gravity feed system. And all of these devices actually consumed water. You know, you see the steam coming off and the like. So needing to have a water supply for these became important as well. So I think it's this new era of machines actually needing water themselves may have been the reason for having additional cisterns available.
So, could answer a couple of questions here. Why is there a mountain up there to start out with? And what's their water doing up there on the mountain? All right. This is a very generalized geological map of the state of Virginia. And you can see a certain fabric to this map here. It's all of this stuff right here. And this is because we've been involved in a tectonic kind of collision back and forth with parts of Europe and Africa for a while. Right now, this is a passive coastline. The active part of the tectonic plate, the edge of the tectonic plate, is way out in the Atlantic Ocean. It runs through ice and stuff right now. But that hasn't always been the case. We've been back and forth and back and forth. But right now, we're kind of on a passive margin. A lot of this stuff was accumulated from other continents as we hooked up with those other continents when we pull apart and leave behind little chunks here. And all that in the Piedmont area, those are called suspect terrains. And pieces of that, as I said, come from Africa, Scotland, different parts of Europe, and so forth. Right now, the coastal plain here doesn't show that, but if you were to look underneath it, because this is just a pile of unconsolidated sediments, this is basically the ocean floor that's being revealed right now. In times past, the ocean has been all the way up to here on the fall line. Okay, so we've got this series of collisions here, and when we pull apart, that weakens the crust, and you get magma coming up, and it's usually basaltic type of magma. Okay, and we're in here, and we're going to talk about a little bit about a couple of those units. One of them has to do with those extensions of basaltic magma, and the other one has to do with some debris that was shed from it. Can we do the next slide, Garth? Okay, so we're here, right? These different colors indicate different types of geological formations here. And there's two that we want to really focus on. And that's this blue one right through here, and this beige one right through there. Here's Mount Jefferson, Lewis Mountain, and these are the high points. This is the higher topography along this brown one, and this is the lower topography along this blue one here. The blue one there is called an amphibolite dike. Amphibolite is a rock that's made out of mostly amphiboles. The amphiboles are very complex silicate minerals, and they have like magnesium and iron in it. And if any of you've ever played sports down along the edge of that thing, you'll notice that your clothes get all stained with iron. And that's the iron's coming out. When that amphibolite deteriorates, weathers, turns into clay, very iron-rich clay. Over here, very different. This is a sedimentary rock. This amphibole is an igneous rock, okay? This is a sedimentary rock. And this is basically composed of quartz grains, and we're going to go up there and look at this a little bit. And quartz is very different than amphiboles because it's very resistant. Quartz is one of the most resistant minerals on the earth. And when you think about it, when you go to it often deteriorates into sand. If you were to go to a beach, most beaches, that sand is quartz. It's the most resistant thing. All the clays have been washed away offshore, the sand is left. And that's more or less what happened up in here. So that quartz, because it's so resistant to weathering, keeps those mountains up there proud. Whereas down here, weather's down, so this is your low country. All right, now In terms of water capacity, they're two very different things. This, as I said, deteriorates into clay. And clay has a tendency to grab water, bond it within the molecular structure of it, and not let it go. Whereas up here, we've got poured sand, and that's just kind of like you would have at a beach. When the water runs out, the sand drains out. And so there's a lot of interstitial area, a lot of areas between the grains here that can hold water. So when it rains, it goes down there. Down in here, it runs off. Okay. Now, that's kind of the long and short. We'll go up there. We'll take a look at this. There's a nice little place where they blasted out behind one of the buildings up there, and you get a good look at the geology there. Okay. Now, if any of y'all got any questions, save them for when we get up there. Tuck them in the back of your head, and I'll be glad to answer them up there rather than take up the group's time out here. All right. So I'm going to adjourn for a little bit. I'll meet you guys back up there at 1:30. Is that 1:30 up on the side of the hill? And so save your questions for that if you've got any kind of questions. And I will also have this map with me so we can point and look and do all that kind of stuff. All right? Okay.
When you were talking about the tectonic plates,
Mm-hmm.
and that some of that land from Africa or Scotland,
Mm-hmm.
when would that be?
Well, it's a series. It's happened several times. Those are called orogenic events. And the last one was the Appalachian orogeny, which folded up all the Appalachian mountains. There was another orogeny before that, the Taconic orogeny, and there's another orogeny before that, the Acadian. So those basically stretch from the Appalachian orogeny is in the Pennsylvanian area, period, and that would be about 250, 300 million years ago. And the other orogenies were about 450 and about 600 million years. The Taconic, the Acadian, and the Appalachian orogenies. There are also evidences of further orogenies before that, but it's so far back in time that it's a little sketchy. You can date the rocks, but you can't get a really good idea about how they were laid out. So you can't get an idea how they were laid out. That is your question.
And then Mount Jefferson and Lewis Mountain have arisen at what point?
Well, they haven't really risen. The land is weathered down around them, you see, and they're resistant. And so when everything goes down, they're up there. Yeah, exactly. Because this whole thing, what we're seeing is in the middle of a giant anticline. An anticline is a big fold, and this fold is composed of this Catoctin greenstone. And if you were to go over here, you'd also see some Catoctin greenstone. And those are the two limbs of the fold. The fold, it runs all the way up into Maryland. And when the fold was pushed up, and this is a major fold, and there's another one, the down fold, which is over in the Shenandoah Valley. It corresponds to that. When it was pushed up, at the top of the fold is where it breaches. It breaches easily because you get most tension up there, and you get also the most compression up there. So the rocks fail. And so the resistant Catoctin greenstone, which forms Carter's Mountain, Southwest Mountain, et cetera, right on up to Catoctin Mountain in Maryland, and also forms the backbone of the Blue Ridge. Those are the limbs that are left from this big, like a kind of a cathedral-like fold that runs for several hundred miles. Okay, sure.
Okay. So water flowing down from the 5 springs that we'll see today join up with water coming down from the south side of Lewis Mountain and join together about 200 feet from Alderman Road, right at Facilities Management. The water flows slowly down on the east side of what will become Emmett Street. Historically, it has flowed in a small channel during periods when it was a perpetual spring and very wide during major storms. At certain times, the university has done some earthwork and created a low dam to create a pond. Looking west in this 1915 photo on the left, we can see a residence across there that will become a fraternity house at some point, and today is Alumni Hall. There's a service road over there, and that will become a state road in 1931, and that's Emmett Street. And then on the right,
Can you show us with the pointer?
I'm sorry?
Can you show us with that pointer when you're talking?
This is Alumni Hall right there. And then right along in here, there was a service road that ran basically right along the property line between UVA and 1915. A little bit further along, that would have been the anatomy professor who owned the property and ran a farm at the southern end of that property. This had all been subdivided into private homes, but there was a good portion of it. And
That was Professor Emmett, right?
actually, 1915, it was no longer being used as a farm. It was actually, the family had subdivided it, and I think it was for sale in 1911, because that's when Lambeth bought this, like one of the earliest lots there in 1911. So, but that's at the south end of the property there.
So could I just amplify that, Garth? For those of you, just to make sure you're oriented, this is what's called Nameless Field now, at the corner of Emmett and University Avenue. And it's the site where the men's gym now sits, the tennis courts, and the volleyball court. So you can imagine, it's sort of hard to imagine, but this is what it looked like 200 years ago.
And Nancy, didn't it have a big pond down in front of the gym?
We'll get to that.
We'll get to that.
Yes, but this was the site of where Meadow Creek was landing and Nameless Field.
This plateau right here is where men's gym will be built. So, let's say on the right-hand photo, that's one looking north along the pond. So Jefferson made a good friend with a Portuguese botanist and naturalist named Abbe Correa, who was visiting America for 8 years. During a visit to Monticello, Abbe wrote a plan for a public school with 4 acres devoted to 1,500 plants with very few Virginia natives, and a 2-acre plot that would be dedicated to trees and not have a native tree from Virginia. Jefferson adopted the plan to the land adjacent to the road that descends from McCormick Road down to Meadow Creek, today's University Avenue. And that's conceptually on the right-hand side there. Right in there. So here's the trees, there's the plants on the west side of Meadow Creek, and this would probably be Chateau front and back, I think, from the drawing. His plan also was to include a serpentine wall around the 4-acre plant site. Jefferson charged this to John Emmett, the chemistry professor, and Emmett sort of fought back, saying that he was busy enough with his work, and but Jefferson said to him that he needed to expand his sphere of responsibilities and needed to do this to make the university work, and so Emmett went to the proctor and explained what Jefferson wanted to do in building this garden space. But the big push at that time was finishing up the rotunda, and there were no hands to spare, so that had to wait. And after Jefferson's death in July of 1826, Emmett waited until October, but he wrote to the BOV and explained how busy he was with his chemistry lab and the like, and that doing the work on the botanical gardens and also trying to work on the other efforts that Jefferson had wanted was just going to take way too much time. And 6 days later, the BOV wrote back and said, agreed, we'll put that aside for the moment. And so the whole concept was shelved.
But Emmett's house is still there, and the garden around it.
Is that right?
Yes,
Okay.
it's in the Lewis Mountain neighborhood where I know. It was built in 1832, and there's a plaque that describes the house, and then people were allowed to walk around the property and see the garden.
Well, I'll just mention that the research on all of this was done by Lily Fox Bougere for her master thesis in architectural history 10 years ago. And these illustrations were done by Jenny Jones. And it's really nice work that the two of them did. There was also an exhibit at Special Collections maybe 6 years ago, I think. So here's a 1917 plan for botanical gardens down in this area that would be Nameless Field. This is the chemistry lab that burnt down in 1916, was rebuilt in 1923. It's the 2-story biology building that became Miller Hall and admissions, and was taken down and is approximately the same footprint as the Harrison Institute and the entrance into the small Special Collections Library. But they've got it labeled here as ice pond, and on cold enough winters they could actually collect ice here. And I circled these 2 spots. It's actually where they dug down and created pits to put ice in and store it for the summertime. And there is a photo. It was given some nickname of Lover's Den or something like that as well, in the Special Collections photo collection. But there was also one of these pits on Carr's Hill as well. The creation of Campbell Hall covered over that particular pit. And here's the real part. They included an amphitheater right on the edge, no doubt as the teaching spot for the biology. On this, someone penciled in the walking paths that are in place, and also drew in a couple of observation areas. They've projected a bridge here to connect so that they could actually circumnavigate right around the edge of the pond. After the Civil War, the Miller Fund made money available for the study of agricultural chemistry under the School of Chemistry and collaborating with botany. Test gardens like in the lower left, lower right there. There we go. This is a map of a test plot, and this would be a 1/4 acre, and what they're delineating there is what was spread, you know, like 100 pounds of Acme phosphate, and then above it was another 1/4 acre, and that was 100 pounds of ACE phosphate, and up here might be 66 pounds of ACE phosphate. So they're trying different combinations here, and they're leaving a buffer space in between each of these, and then they broadcast one type of seed evenly across, and then they're looking at germination, they're looking at yield, they're looking at quality, and seeing if there's any differences there. So, you know, somebody's saying ours is the best phosphate, here's where they're going to find out if it's worth the difference in money and life. So these were all the experiments that they would do, and they would also be doing, you know, things with fertilizers and the like.
And who is the photo?
And this was all done through this Miller Fund. But this very elaborate and exquisite survey that was done by Professor Dunnington is to delineate this area right in here that he's going to develop as a test area for a series of experiments. The largest area was actually the site of where Scott Stadium is. That was a very large area. It was fenced in, and they were actually at the point of even testing various plow types. That's how elaborate it was getting. And they had housing out there for the farmhands that work.
Is that Dunnington up in the photo, the picture?
I'm sorry.
I think I can help answer some of this. I'm going to cobble together what I kind of remember.
Is that Dunnington up at the top?
No, that is Samuel Miller. And, you know, it's a name that is quite familiar to us now, living in the Samuel Miller district. He grew up in Albemarle County, very destitute conditions, lived in a house that I understand didn't even have glass on the windows, and he never went to college. But he moved to Lynchburg and became quite prosperous, running a fabric factory there. Accumulated a tremendous amount of money, and so he came back to Albemarle County, gave a generous gift to the university when it was at a point of near financial ruin, because of the Civil War, after the Civil War, as Garth was mentioning. So the money he donated he intended it to be to develop this experimental farm and a short-lived Department of Agriculture right here on Nameless Field. Again, sort of stating the point that like Jefferson, who wanted to build the Botanical Garden in this site because of the water, this idea also to do an experimental farm happened because of the waters here.
Thank you. Here's the farm.
So, this is a 1896 map of grounds, and what's peculiar to this one is what's on the pond here. In this case, they've called it a skating pond, and not sure if it's delineating a new interest in skating. This is a time in which things are evolving. I mean, tennis really just came into vogue like in the late 1880s and stuff. So maybe this ice skating came into vogue at this time, and that's why it was done. Or maybe it was 1896. The lawn is a construction site. At the north end, they're rebuilding the rotunda. At the south end, they're building the two laboratory buildings and what is now Capitol Hall. So it may have been a diversion for the students to look forward to the cold weather, have their skates ready. And that's a defect in the glass. It's not an inflatable pyramid or anything like that. Or I Am Pei's entrance to Chipotle or something. So Fairweather Gymnasium had become small for the growing student population under President Alderman. With about 80 student and faculty members being lost during World War I, the idea of a memorial gymnasium seemed favorable. When solicitations went out, they came back with money. This was going to be the largest building on grounds. It needed to be removed from the central grounds. The new architectural commission could work it into the symmetry of the lawn and draw on Roman classicism for its city beautiful look. The reflection pool was actually a retention pond. Meadow Creek poured in the southwest corner and overflowed out the north end. In the mid-50s, the creek was diverted into a pipe and the pond was filled in.
That's Emmett Street today, right?
Yeah. And this is actually a road, but it's also reflecting a little bit of the topography. But this is really sort of the outline of upper Nameless versus lower Nameless as well. Just taking some heed to the natural topography, I guess, of the time. Sorry for the lightness of this. It's a very large drawing. It's probably 9 feet in length here with rather fine lines. But in in 1936 a schematic plan for a botanical garden that actually starts way down on the right hand side at Emmett Street and then comes up to the area of the cemetery and then all the way over to what is today facilities management. And it's faint, but they have a large sort of surveyed area that might be a large garden is all done here. I'm just judging by the time period, 1936, that this may have been something in the way of a New Deal project, potentially. 1936, we're finishing up the library, which was a pretty successful use of a lot of men and the like. You know, nobody worked 40 hours building Alderman Library. It was 36 hours. That meant more people worked. And so maybe this was an idea for entertaining something, but nothing came of this. But in 2004, we had the Dell Stormwater Management Project, and this was actually as a way to address stormwater, and it was done here, but the credit was for the John Paul Jones Arena. You didn't need to do, at that time, you didn't need to do a project at a site. You could take credit for something at another place. So this was done using funds from the John Paul Jones Arena to work on Meadow Creek, and this was where the water came down, went into a weir, W-E-I-R, and dropped into here. It was a settlement pond, basically, so that it had time for the solids to drop and then flow into here and then move into piping to flow through. Warren Bird was the one that did most of the landscape design, and his scheme was to take the three primary geographic areas of the state. You had the Tidewater area, the Piedmont, and then the Highlands, and that's the plant material that he chose for these three areas as the design went. And I think biohabitats dealt with a lot of the working of the flow of the water in a sustainable way. Yes.
Stocked with koi, and then later on other fish in the pond, and people will come and fish there now.
I think so. So, and of course, this was on the site of Landis Italianate Gardens, which had basically deteriorated in this eastern portion. There's a few features that were maintained back up in here.
The arch is still standing.
So that concludes my talk, and at this point we take a short.
Okay, so Garth's portion of the talk was really referencing the early days of the university, really focused on the Academical Village and some of the issues of getting water off the cisterns. And then he was talking about the evolution of Nameless Field, going from that kind of swampy area down below and evolving through various visions of gardens, and ultimately the reflecting pond at Memgem. And it's so interesting today that that field is now dry. There's absolutely no sense of there ever being water there on that site. So I'm actually going to be talking about a period later, moving into the later 1800s, and talking about the expansion of the university from the Academical Village westward. So we start with this map. It's a very well-known map, and one that you can actually see in special collections if you're interested. It's called the Pratt map. And just to orient you on this map, we have a problem with our little remote here. Okay. Here is the Academical Village, and this was the drawing that Garth was showing to you earlier with all the C's on it that are marking where cisterns were. University Avenue is running through here. We have a nice line here, that's Emmett Street, and Mem Gym was then ultimately built in this area. And we can start to see the beginnings of what would ultimately be McCormick Road, which would be paralleling Meadow Creek that would run through here. And I'll point here also to the annex here that was at this time built in 1853. So at this point, the Board of Visitors decides that it needs to hire somebody. The Board of Visitors realizes it needs to hire some professional help on its staff to organize to keep overview of the university grounds and to supervise the construction and the maintenance of its buildings. So they hired William Pratt, who was an architect and whose work you might know here on grounds. He actually designed the Varsity Hall, which is the infirmary, the medically significant building, an old infirmary that sits behind the comp school and is on Hospital Drive. But William Pratt then came in 1858, and he became the first superintendent of buildings and grounds. So this is a watercolor and ink drawing that he produced, and it's again, it's at Special Collections. And it explains Pratt's plan for how the university was going to expand physically as the university is growing. So interestingly, we can just spend a moment looking at something that's not so related to water, but here, the southern end of it, Pratt had a vision for expanding the university with a series of buildings that were gymnasium, a parsonage, an infirmary, I forget, so those general buildings that were to be located along these meandering paths, kind of in the picturesque landscape style of that period. And we can certainly notice very clearly that it was not at all in the style of the neoclassical order, the geometric order that Jefferson had employed for the lawn. But we can look at this and know that this was not built. In fact, after the fire, the work of McKim, Mead, and White produced Old Cabell Hall framed with Koch and Roshau's down here. But Pratt did have a vision for expanding the grounds out to the west in that land that was heading out towards Observatory Mountain. Now the fascinating thing about this drawing is that there's this beautiful watercolor drawing, but all over it are pencil scribbles and notes, almost as if Pratt was using this drawing as a kind of working drawing for what he was planning for the university. So for instance, as he said, he was just write C's on the drawing wherever there was going to be a cistern here. But in this drawing, because it's all very light, I've taken the liberty of adding these red lines here that show you the additions that he was proposing of moving westward. So it's listed as the 10 professors' grass lots, consisting each of 4 1/4 acres, and then a series of lines here that are denoting 10 professors' gardens, each 1 acre. And so Pratt was dealing with a problem, an initial problem with the initial vision that Thomas Jefferson had. Jefferson thought that they would use the space in between the garden, in back of the pavilions, as the kind of working living space for the professors. But as it turned out, it proved that it was noisy, it was messy, it was probably muddy, and it was way too close quarters to where the professors were living. So Pratt was making the first proposal for expanding outside the Academical Village by going west. But the thing that I think that's interesting, and again, part of why we claim that
the water from the hill was so important is that each one of the parcels follows Meadow Creek running through here, through Nameless Field. And so each one of the parcels had access to the water that was flowing down. And of course that water would be really critical if you're, for the animals that you're raising, for the crops that you might want to be growing in this area. So even though water was flowing down from Meadow Creek and flowing down to the university, there were some problems. And first of all, it's very interesting. You can go through the Board of Visitors meeting minutes and find several references to prolonged droughts that were happening in the years after the opening of the university. So just my initial kind of perusal of it saw that in 1852 there was a mention of the drought. 1869, 1873, just 4 years apart. References to droughts, and the board kind of wringing its hands. What are we going to do about the lack of water here? So I just sort of read one of them. It says, in addition to the 3 old cisterns, 3 new ones have been added within the last year, and that would reference what Garth was talking about. The drought, which has prevailed for the last 18 months, has so diminished the supply of water. Resolve, therefore, that the proctor be required to cause additional cisterns to be constructed. So in addition, though, to the drought, there's a record of a serious pandemic that broke out in 1857 to 1858, and that was for cholera and typhoid, which would have been caused by unsanitary conditions, poor drainage, and contaminated water. So these 2 conditions of droughts and a pandemic outbreak, as well as a growing university. At this point, the university had grown almost to 600 or 700 students from the original 109 that started out in the Academical Village. So there was a period, as mentioned earlier, the Civil War. There was the enrollment at UVA dropped precipitously. The university was almost in financial ruin at that point, but following the Civil War, it started to grow back. And so by 1900, I think they say there were 700 students. But all of that, the increased demand on water, more students, along with a pandemic and along with a series of droughts, were causing problems. And the Board of Visitors realized that they really needed to take some action here. So they called in the very prominent civil engineer of the time, Charles Ellett Jr., to come to the university and help them deal with the water problem that they had. This is a fantastic map. It's also in special collections that you can view. It's a good size map with obviously some wear and tear here on part of it. But luckily the tear happened so that it doesn't disturb the thing that was really critical, where Ellett was looking at how to get water from the extreme parts of the ground and get it over to the Academical Village. So this is an overlay of what was proposed. The dashed line, the blue dashed line, shows you where the stream from Lewis Mountain and from Observatory Mountain were coming down and joined near facilities management, and then continued up towards the rotunda, the Academical Village, and then northward where it would ultimately connect to the Rivanna River. And then the red line shows where Ellett was proposing a new network of cast iron pipes that would replace the old wood pipes that Garth was referencing in the Thomas Jefferson survey. So the cast iron pipes would be laid here following the creek, and then at some point part of it would diverge down to Monroe Hill, but the other part would move up here northward and land at the base of the annex building here at the rotunda.
And when are we chronologically right here?
This is 1856, 1858, no, 56.
56, yeah.
Mm-hmm. So let's take a look here at this map. I'm going to pick it apart a little bit and first look down at this area where it says Observatory Mountain, and then we'll come up here and take a look at this area up here by the rotunda.
So in the detail of this area at Observatory Mountain, I've blown it up here, and there is the springs that are noted, and again, these are the springs that Jefferson knew all about in his acquisition of the land. And the red, but there's a curious box that's on the map. It's a hard rectangle, and there are no notes on the drawing, nothing that records what this is all about. But Garth and I feel quite confident in saying that this was Ellet's proposal to build an upland reservoir up right below the springs where the water was coming out as clean as could be. And so the rectangle, again, it's never been confirmed, but we can go out there today and there's a giant hole, a giant reservoir that is built there. Now, so Ellet's claim, and this was a relatively new idea, to hold water up at the top of the hill when water was available so that during the dry seasons, the water flow could be more continuous. It seems very logical to us and something that we take for granted nowadays, but in that day and time, the public was very skeptical about this. They didn't know about drinking water that's been sitting up there for months. They thought it was, could be stagnant, if not contaminated water. But somehow Ellet prevailed, and so the reservoir was built, and it can only be imagined what that was like when we go see it, what that was like to dig through the rockfish kilometers, to dig so many feet down into the rock. That was that end of it. Oh, and here's this lovely picture in special collections. I'm going to sort of make some guesses here by the vegetation and the fact that she's wearing this lovely dress, that this might have been summer or, a warm season. And we can see there's water that's sitting in the reservoir. So Ellet's idea that we hold this water here for later on for distribution down, I think holds. And I always take personal credit for noticing that I think she was there with her dog, swimming in the reservoir, which I guess if you think about it is not exactly what you want to have swimming in your reservoir, but I think it's a delightful part of the photograph.
What's here now?
We'll see it. The hole is there, but it's dry. So now we go to the other end of Ellet's plan, and let's take a look to see what was proposed up at the top. So here's a blow-up of it. So Ellet's plan called for cast iron pipes to be brought up here to the base of the annex here, of the rotunda, and it would land in a pond. It's actually drawn as this kind of little scraggly shape here. And then somehow the water was going to come up to the annex. And so this gets at what Garth was saying before, that the water would be pumped from a pond. If we're standing right here looking at the rotunda, this is the view that you would have seen in the 1860s. So you look across this pond, you can see it's a little bit scraggly, the water level would be changing seasonally, some trees were growing up around it. So the water would be pumped to the basement of the annex, and Garth, you're saying it was pumped to this part of the annex, I believe, to here, and then it would be pumped up to the roof of the rotunda. And again, whether it was the portico or over the library, we're not sure where those tanks were actually located. But this was the plan, and it was executed. Now, at some point, they decided to take the open pond of water and to bury it out of sight, to put it in a subterranean vault, which has been documented and actually, as I understand, still exists under the ground up in this area. And so the idea would be to take the water that once sat on the surface in this kind of murky pond here and bury it out of view. And here it is. It's made out of brick and made out of stone here. Why they would have done it, I'm not sure anyone really knows for sure. I could suspect one thing, that perhaps they didn't like the look of this pond here at the base of the kind of the magnificent rotunda and the annex. The other one could be that maybe they wanted to keep the water a little pure by having it buried and protected underground. But Garth, I just was thinking about this the other day. I just realized that the chapel was built in 1885,
And perhaps it would have been the building of that which would have prompted the superintendents or whatever to want to clean up this area and make it more in keeping with this new chapel that was being built there. But that's all speculation. Don't know. So, despite the fact of putting up the water up in the roof of the rotunda to try and add some fire security, it was all for naught. And we know that because in 1895, the Great Fire happened due to an electrical explosion that happened in the northwest corner of the annex. And so the annex and the rotunda were lost to fire. Okay, now we're going to move away from the Academical Village. I'm going to bring you up to the hill here, and we'll actually be viewing this site here later on. During this period, there was a lot of pressure. There was a lot of interest for building new buildings at the university, particularly science and new technology buildings, some of which were related to war activities, like the Naval Ordnance Building, where Jesse Beams was doing experiments of the Manhattan Project, to other kinds of buildings that are up there now, sort of science buildings that are part of the Cold War era. These are buildings that needed to be somewhat isolated, you know, still in the context of UVA, but they needed to have some degree of seclusion. So these buildings moved up to the hill, and there are a whole series of them. One of the buildings that was constructed as a part of this was the new experimental nuclear reactor. And this was built in 1958. And we're going to go see this building. It was part of UVA's plan to join. Many universities at this time were opening up nuclear engineering programs. They saw the possibilities of nuclear energy, no longer for military purposes in the war, but now the vision was that this new form of energy would power cities and would light up homes. And so there was a great amount of energy to create these nuclear engineering programs. And at the time, it was very successful at UVA. The record shows that there were about 60 graduates every year from the nuclear engineering program. So it was a very, very prominent program. So here are the architectural drawings for this building. And this circle here is the containment center here that you can see, that we'll see later. Oh, actually is figured here on this contemporary picture. So if we look at the architectural site plan of it, we can look and see that there's something described as a waste pond over the existing pond. And this was the reservoir that Charles Ellet had proposed and got built up on top of the hill, right on top of the hill. So the reservoir that was designed to create continuous flow of clean water for the university now became the waste pond for the deposition of various materials, I wouldn't even know what to call them, that were products of the nuclear, of the reactor. Now, I should say that it's been told to me that this was a very low-level producing reactor. It wasn't hardly something that was a major one. It was really designed for teaching and for research. And that there was only one record of a time when the plant had to close because of leakage into this pond. But even with in like 1997, they added groundwater monitoring wells between the building and the pond, and as a way to ensure that radioactive leakage, was not happening into the pond. As it turns out, we had 3 Mile Island catastrophe and Chernobyl, and the country lost its appetite for nuclear engineering. Enrollment in the program plummeted, and so the university decided in 1998 to close the department, and they decommissioned the building. It took about 5 years to decommission it, but almost every surface you can find actually drill holes in it. They were testing surfaces of the building and in the pond to make sure that there was no radioactive leak. So another story up on O Hill, again, at this point, the university had grown even further. By 1929, we had over 2,000 students here at UVA,
Household kitchens were moving indoors. The university was building buildings with more plumbing, demands of the systems there. And so UVA, again, was wringing its hands trying to figure out how to attend to this increased demand for more water and improved water quality. In 1888, the state legislature authorized construction of a municipal waterworks. And the BOV, totally fed up with having to find water for this university, went into a joint venture with the city to share the costs and the benefits of clean drinking water and greater fire security. So the plan hinged on the construction of what we now know as Ragged Mountain Reservoir, but roughly 4 miles out to the west of the university. And so construction began in 1887, pipes were laid, trenches were dug, and this dam was built to house the new Ragged Mountain Reservoir that opened in July of 1888. And so at that point, water was flowing freely down to the university and to the city, and the entire picture of water changed for this area. So the creation of this new reservoir immediately and effectively terminated the university's dependency on Parcel 1B for its water. However, Parcel 1B would continue its role in servicing water for the university. And that is because we can look at a site that you'll also be visiting, the water treatment plant. So after the opening of Ragged Mountain Reservoir, the water was still coming to the university, and it sat in open reservoirs, circular reservoir, up on a site that sat right above Scott Stadium. There's Scott Stadium here, Alderman Road, and this is McCormick Road, and you can see some of the development of buildings that were happening there. But this circular reservoir sat up here and was the holder of water that was putting water, distributing water down to the university. But at this point, science and technology had improved, and the engineers wanted to set their sights on doing more than just storing water in open ponds. They realized that they could do a lot more to treat the water to make it reliably clean and safe to drink. So in 1923, I think, the observatory water treatment plant was opened on the site of this old reservoir. And so we can begin to see facilities here. It was a whole game changer. The water would come in from Ragged Mountain. The sediment would settle out in ponds. It would go through chemicals, and then through a very elaborate sand and charcoal filtration system that was able to really do a great deal in cleaning the water. So we can look at this slide here and compare kind of the old story of water at UVA and the new story. So here is the old story, Jefferson Spring that he knew about, flowing into Meadow Creek, past the Academical Village and up north to the Rivanna River. And it served the university for good, well, not 100 years, but a good amount of time. And then compared to the construction of Ragged Mountain Reservoir in 1888, and then ultimately the facility, the observatory water treatment plant in this area that would clean the water and then distribute it to the city and down to the university. So we just want to close our talk today with two slides. The first one is looking at what was the existing condition of Meadow Creek when it was first found. And it's this blue line that comes here. Again, comes up through Nameless Field, past the rotunda and the lawn, Academical Village, and then daylights out at Lambert Field dorms. So everywhere that you see a blue area, light blue area with a solid line on it, that's here and here, are places where Meadow Creek still flows free. It's an open air stream, trees are growing along it. And everywhere you have a red square with a dash line on it represents where Meadow Creek is buried underground in a pipe.
And they're planning to daylight it out in front of the new data science building.
Exactly. So if you take a look then here, Nameless Field, remember it's dry right now, right? The fields, we know the volleyball, it's no water, signs of water, it's all underground in a pipe. And so when we look at it, we can say, gosh, like 50% of Meadow Creek is now underground in pipes. The one bright spot in this story is the Dell Park that Garth was talking about, where we claim that Jefferson's vision for a botanical garden was finally realized. And so here, where Meadow Creek once ran underneath in a pipe, it's now been daylighted and created this wonderful public amenity. And I have to tell you, the Dell Park, was an incredibly important park when it opened in 2005. It was the first example of taking the water, daylighting it, and not just treating it in a utilitarian way, but creating a beautiful public park that was also a bit of a working machine, because as Garth described, that pond is actually working really hard to remove a lot of the sediment that's there. So I just want to close with this slide and close out our talk on the story of water and its impact in shaping the early and the current university. These photos remind us that there are hidden stories of water all around us. Today's talk hopefully informs you of the rich history of water that flowed in open streams and ponds around the campus. They're now buried and they're hidden from daily contact. In this day of growing environmental awareness and health well-being advances that make us aware of the benefits of encountering nature in our daily lives, we should reconsider the place of water on our campus and treat our waters as a legitimate part of UVA's history, culture, and storytelling. So it's our hope that UVA will continue its important work to restore and respect waterways and interpret this resource to the community and to the public. Thank you.